And it's legit.
And I'm Elizabeth Langley.
So, the optimal location within a market, which is the best location within a market, obviously depends on the hierarchy of services and settlements, and it's legit.
And small settlements are limited to small thresholds and ranges in consumer services.
Large stores can't survive in small settlements because they don't have enough people. They'll die, obviously.
And consumers travel long distances for low prices.
Awkward starfish. So it's time to say the Pledge of Allegiance. Let's go. I pledge allegiance to the flag of the United States of America, of the United States of Rock America, and to the republic for which it stands, doesn't sit, for which it stands.
Wait, Murphy's not saying it.
Oh my gosh, are you kidding me? He's in America, but that's cool, because he's from England or something, or maybe Poland. I don't really know. I'm not really sure. Do they speak English in Poland?
I think so.
Then he's probably from Poland, obviously. So it's okay if he doesn't say the Pledge of Allegiance to America because he's from Poland. It's legit.
It's the turn of the chapter.
Too bad it's out of my range, which is the maximum distance to travel to the mall today.
Okay. MDCs have many small settlements, small thresholds, and ranges. There are 4 levels of market area: hamlet, village, town, and city.
Bank. It's time for how do we do that? The task is make a market area. So, you obviously have your map with orange stars for nodal regions, nodal areas actually, nodal points actually, and your people on it. So, you're going to get your handy dandy marker, uncap it of course, and you're going to draw hexagons based on the size of the nodal points. So, we're just going to draw a few here and here, and they can't overlap, remember, because these are hexagons. So that's why they make hexagons. Hexagons. So, here we have it. And the closer to the periphery it is, which is the node, it means more people will go. So Tom here will go here, and then Eddie over here will go there, because it's closer to that node point. That's what we learned on how do we do that?
It's the turn of the chapter. Oh my gosh, there's nowhere to get makeup.
Oh look, the makeup store.
At a market center. Yeah.
Oh my gosh. Look at all these people coming from surrounding areas to my central place for makeup. What are we gonna do?
No more ugly.
Yay! Central place theory.
Theory applies best in areas barely industrialized and under-interrupted by major physical features. It's the turn of the chapter.
She's just not enough to support me.
Threshold. The minimum number of people needed to support a service.
Oh my gosh, I'm ready to get out.
There we go. It's time for how do we do that? The task is the rank size rule. And the rank size rule is obviously ranking settlements from largest to smallest. So it's obviously a pattern. So the nth settlement, which is like X, which is like a variable, thank you, Mr. Forrester, for that one, is obviously 1/n of the largest settlement. So here you got your large settlement. Goodness, okay. Here you've got your largest settlement. So let's call it large settlement. And large settlement, small settlement. The second smallest settlement is 1/2 of large settlement. Okay, so we've got large settlement. So the third smallest settlement is 1/3 of small settlement, the large settlement. You get it? Good, because I'm not saying it again because it's confusing. Okay, so the primate city rule. Primates are like monkeys, but I don't know why that's primate city rule. So the primate city rule is the largest settlement has more than twice as many people as the second largest settlement. Okay, get it? So like, large city has 15 people in it, and small city over here has 2 people in it. So obviously that follows the primate city rule and not the rank.
It's the turn of the chapter.
Hey, come get some flowers for your girlfriend.
Come buy some cute little
Yay.
Hey, I've been looking for Kat.
Oh, there we go.
Yeah, but someone needs to buy a guitar because they're guitars.
Flowers.
Tennis flowers. Oh my gosh, I've been looking for flowers. Cool.
Yeah. Well, someone
Dude, give me a guitar.
Yay.
Periodic market. A collection of individual vendors that come together to offer goods and services in a location on specific days. How do we do that? The task is find the best location for a settlement in a linear settlement. Actually, the best location for a service in a linear settlement. So obviously a linear settlement has linear homes on it that you can divide in half, okay? So the best location for this linear settlement and any linear settlement is so that half the people are to the north and half the people are to the south. So the best location is obviously the orange smiley face. Now it's time for how do we do that task number 2. Now, it's how do we find the best location for a service in a nonlinear settlement. So here we have our nonlinear settlement, and the possible location is obviously the caterpillar. So what we're going to do to find if this is a best location is we're going to identify every potential customer, and the houses are the potential customers, and divide the distance from there to there by the number of houses. So take out your handy dandy calculatrice if you're speaking French and calculator if you're speaking English, and you're just gonna like calculate that up, and it's like the mean, like obviously like Mr. Forrester taught us how to do that. So, and the answer is obviously 2.4545. So then you're gonna find another possible point and do the same thing, but this location may be 6.701, obviously, because that's just the obvious answer. So then, obviously, this would be the best place is the orange caterpillar because it's closest to all customers. It's a party, it's a party, it's a party.